and let's try to do it faster. So I would like to present the screen of our surface areas volumes class in PDF. Okay, so it is class 9. Please concentrate and pay attention on this chapter because the same will be repeated in the 10th. I mean, like, there will be some more a little bit changes in the 10th chapter, exact chapter we have. So I'll just give you a clarity about the 10th class surface areas and volumes, about how it will be and what all. So yeah, without any further delay, let us start. I'll just present the screen for you people. So as you can see, this is the surface areas and volumes chapter. Now I'm going to just give you a little bit clarity. How will we have it in 10th? That means in this chapter we are especially going to learn about the surface areas of particular what we say particular um, objects. I mean, which can be figures. Okay, so we can call it as solid figures, right? So here we are going to learn about 6 solid figures, very like which we actually are aware of from our childhood. So we are going to just know something, explore something new in this chapter 13, surface areas and volumes. So in 10th class, you have it as same 13th chapter, 239 page number. I have it. So yeah, what are we going to learn here? What are we going to learn here? We are going to learn about cuboid, cone, and all such things as we already have learned it in our ninth class. What we are going to do in this 10th, we are going to see about 13.1 is totally dependent upon our ninth class textbook only. We should actually what is it is they will ask the curved surface area of cylinder, you have to add it with hemisphere. Okay, it's very easy guys, it's very easy. You formula equals to, okay, then volume, adding the surface areas of different objects, adding the volume of different objects. Okay, for example, you are throwing, you're pouring water from a cube to a cuboid, then what will be the volume? Converse, a conversion of solid from one shape to another, that is also there. So in this 10th class you have only 4 exercises. Fifth one is optional. Okay, this is not from an examination point of view, but it's better to read, go through it. Okay, so yeah, as you can see, we are going to do surface areas and volumes. Let's first read the introduction of class 9, then we'll go with class 10 starting introduction. Okay, only starting introduction, because it will be like we will learn something a bit advanced, a bit. Okay, so that it will be easy for our 10th and ninth also. Fine. So let's go with our class 9's introduction, then go with class 10. So please, like, stay aware. Don't dream here. Let's start with our surface areas and volumes chapter without any further delay. So yeah, without any further delay, let us start it, guys. So as you can see, the introduction, we are going to read it. So let us start. Whenever we look, usually we see solids. So far in all our study, we have been dealing with figures that can be easily drawn on our notebooks or blackboards. These are called plane figures. We have understood what rectangles, squares, and circles are, what we meant by the perimeters and areas, how we can find them. We have learned this in earlier classes. It would be interesting to see what happens if we cut out many of those plane figures of the same shape and size from cardboard sheet and stack them up by the vertical pile. By this process, we shall obtain some solid figures, such as a cuboid, cube, a cylinder, and etc. In the earlier classes, you have also learned to find the surface areas of volumes and cuboids, volumes of cuboids, cubes, and cylinders. We also learned to find surface areas and volumes of we shall now learn to find the surface areas of and volumes of cuboid and cylinders in detail and extend the study to some other solids such as cones and spheres. So what are they saying here? Generally, guys, you just see, wherever you see, I have a sphere over here, which is a globe. I have a sphere over here, or I can say I have a cuboid over here. Fine. So everything around us, we see many things which are solid figures. Solid figures are nothing but this only, three-dimensional, such as a sphere, a cuboid, or else you can say you can take a cube, a cylinder. You have many things. Okay. Then you have a cone. So all such things are called solid figures. Generally, rectangle, square, and circle, we know everything about this. So if we draw them on our board, if for example I want to draw a square, I'll draw it on my book. So what is happening? I'm only drawing one of its surface. I'm always able to see one of its surface, right? But when we able to see all the surfaces, which are six sides of a cuboid or cube, this is called a solid figure. So that is what they are saying from the first induction. Going with the next. Surface area of a cube and cuboid. Have you looked at a bundle of sorry. Hmm. Have you looked at a bundle of many sheets of paper? How does it look? Does it look like what you see in figure 13.1? Of course, right? So, for example, I kept a book on a book. Then, see, for example, I kept a paper again on the paper. A4 sheets bundles will be available at the stationery shops. So, when we put all the A4 sheets on one another, we find something like this, right? We find something shaped to be like this. So, this is actually a cuboid because a rectangle, right? So, that makes up a cuboid. How much brown paper would you need if you want to cover this cuboid? Let us see. First, we would need a rectangular piece to cover the bottom of the bundle that would be shown in figure 13.a. Then we should need two long rectangular pieces to cover two sides in ends. Now it would looks like figure 13.2b. Now to cover the front and back ends, we would yeah, we would need two more rectangle pieces of different sides with them. We would now have a figures as shown in figure 13.2c. This figure, when opened out, would look like figure 13.2d. Finally, to cover up the top of the bundle, we would require another triangle, rectangular pieces exactly like the one at the bottom, which if we attach the right side, it would look like figure 13.2 E. So we have used six rectangular pieces to cover the complete outer surface of the cuboids. So please try these activities because you will understand how a rectangle is formed. A rectangle is formed of six rectangles. How a cuboid is formed. A cuboid is formed of six rectangles. This is what it's a summary of this. This shows us that the outer surface of cuboid is made up of six rectangles. In fact, rectangular regions called the faces of cuboid, whose areas can be found by multiplying them by breadth of each of them separately and adding them six areas together. Now, if you take the length of the cuboid as L, breadth as B, and the height as H, then the figure with these dimensions would be like the shape you see in figure 13.2f. So the sum of the areas of six rectangles is area of a rectangle is L into H. So six rectangles, it is when you multiply all of this, then the surface areas of a cuboid will be LB plus BH plus HL, where LBH are respectively the three edges of a cuboid. The dimensions of a cuboid is LBH, length, breadth, and height. So remember this one, which is very important. Okay. The unit of the area is taken as a square unit because we measure the magnitude of a region to be filled it with the squares of side of unit length. So it is measured in the meter square. Sorry, square unit. In square unit, we measure them. For example, if we have cuboid whose length, breadth, and height are 15 centimeter, 10 centimeter, and 20 centimeter respectively, its surface area would be in this way. Okay, we use centimeter square. Recall that a cuboid whose length, breadth, and height are equal are called a cube. Is called a cube. If each of the cube is A, then the surface area of cube would be 2 into A plus A into A. All if you multiply, then you get surface area of cube is 6A square, where A is the edge of a cube. Okay, remember this also. Suppose of very important paragraph of the introduction is this one. Okay, this is important paragraph. Go through this. Suppose out of six faces of cuboid, we only find the area of the four faces, leaving the bottom and the top faces. In such case, the area of these four faces is called the lateral surface area of the cuboid. So, lateral surface area of cuboid of length, breadth, and height is equal to 2lb 2h into L plus B. Similarly, lateral surface area of a side A is equals to 4A square. Keeping in view of the above, the surface area of cuboid is sometimes also referred as the total surface area. Let us now solve some more examples to understand all of this. Okay, so what all you have learned here? You have learned surface area terms. What is a cuboid? What is a cube? Then you have learned about what actually is a lateral surface area. Lateral surface area is also called curved surface area in the case of spheres, other than cube and cuboid and other solid figures. It is called curved surface area. Okay, so abhi lateral surface area is okay. Lateral surface area of rectangle is 2h into L plus B. The lateral surface area of a cube is 4a square. The total surface area of a cube is 6a square, and the total surface area of cuboid is 2 into LH plus sorry LB plus BH plus HL. Okay, so this is clear, right? So now let's go with our 10th class introduction and then go with our examples and exercise problems. So introduction, surface areas and volumes, 13th chapter of your class 10. If you have textbooks, please open it, 238 page number. Okay, guys. So sorry for the disturbance. Let's continue. I can't open now 10th class PDF. I'm just reading out. Try to understand. From class 9, you're familiar with some of the solids like cuboid, cone, cylinder, and sphere. You've also learned how to find the surface areas and volumes. In our day to day life, we come across a number of solids made up of combinations of two or more basic solids as shown below. In our daily life, we come across number of solids made up of combination of two or more of the basic solids as shown above. You must have seen a truck with a container fitted on its back, carrying oil or water from one place to another. Is it in the shape of any four of the basic solids mentioned above? You may guess that it may be cylinder with two hemispheres as its ends. Again, you may have seen an object like the uh, one in figure 13.3. Can you name it? A test tube, right? You would have used one of your science laboratory you in one in your science laboratory. This tube is also combination of cylinder and a hemisphere. Similarly, while traveling, you might have seen some big and beautiful buildings or monuments made up of combination of solids mentioned below. If for if for some reason you wanted to find the surface areas or volumes or capacities of such objects, how would you do it? We can we cannot classify this under any solids you have already studied. In this chapter, you will see how to find surface areas of volumes of such objects. Surface areas of a combination of solids. Let us consider the container seen in figure 13.2. How do we find the surface area of such a solid? Now, whenever we come across a new problem, we first try to see if we can break it down into smaller problems we have earlier solved. We can see that this solid is made up of cylinder with two hemispheres stuck at the either end. It would look like what we have in figure 13.4 after we put pieces all together. If we consider the surface of a newly formed object, we will be able to see only the curved surface of the two hemispheres and the curved surface of the cylinder. So, the total surface area of the new solid is the sum of the curved surface areas of each individual parts. This gives total surface of new solid equals to curved surface of one hemisphere plus curved surface of cylinder plus curved surface of other hemisphere, where TSA, CSA stands for total surface area and curved surface area respectively. Let us now consider another situation. Suppose we are making a toy by putting together a hemisphere and a cone. Let us see the steps that we would be going through. First, we would take a cone and a hemisphere and bring their flat faces together. Here, of course, we would take the base radius of cone equal to the radius of hemisphere for the toy to have a smooth surface. So the steps would be shown as 13.5. At the end of our trial, we have got ourselves a nice round bottomed toy. Now, if we want to find how much paint we would require to color the surface of this toy, we what would we need to know? We would need to know the surface area of the toy, which consists of curved surface area of a hemisphere and the curved surface of the cone. So we can say total surface area of a toy equals to curved surface of a hemisphere plus curved surface of cone. Let us now consider some of the examples. Any introduction more? Yes. So, guys, it's literally very easy in the 10th also. If you go on reading, you'll understand. So, the particularly to find the now, for example, there's a truck. To find the total surface area of this truck, there are different shapes over there. There's not only a cone, there's not only a cube, there's not only a cuboid, right? There are different shapes. For example, there's a cylinder, there are two hemispheres in that. So, to find the total surface area of this truck, we have to add the curved surface area of the solid figures. For example, there is a cylinder and there is a cone in a toy. Okay, there's a cylinder and a cone in a toy. Now, to find the total surface area of the toy, we should add curved surface area of the cylinder plus curved surface area of the cone, so that we get the total surface area. That is easy. That is what is said here. So you have to remember the formulas. Okay. So going with our ninth class textbook back, um, what all we have learned is about lateral surface area, about curved surface, about lateral surface area and the surface area of cube and cuboid, right? So yeah, there's some chart. What is total surface area of cube? Please tip them. Yes, ma. So actually, the curved surface, total surface area of a cube, right? It is 6a square of the because a cube is consisting of 6 squares. So 6a square. You can take 6y square, 6z square. A is just a variable over here. Okay. So the curved surface area of a cube is 4a square. So total surface area 6a square. A curved surface area for say like rectangle, I mean cuboid, is 2h into L plus B, whereas the total surface area is 2 into LB plus BH plus H. Okay, this is what we have to learn from the introduction. Okay, it is the curved surface area of a cube is 4a square. Total surface area of a cube is 6a square. The curved surface area of a rectangle, I mean cuboid, is 2h into L plus B, and the total surface area is 2LB plus BH plus HL. So hope you got it. Let's go further. How much time did we take? 17 minutes for the introduction of ninth and 10th. For these things. Okay. So going with our example one, what does our example one see? Mary wants to decorate. Guys, I want to warn you one thing. Whenever we see the problems which consist of money, for example, there's a 1 meter for second, 1 meter square is 60 rupees. Then what will be the 30 meter square one? We get scared for this type of problems. Yes, I'm right. Even I do. But what you have to think, only multiplication is being done over here. Okay, so not required to worry. Cross multiplication, you people know, no, the same thing you have to do. If 1 meter per second, 1 meter square is 1,000 rupees, then 20 meter square will be how much? That you have to multiply 20 into 1,000. Fine, this is your, then you will get the answer. Clear? So let's go with our example one. Mary wants to decorate her Christmas tree. She wants to place the tree on a wooden box covered with colored paper with picture of Santa Claus on it. She must know the exact quantity of paper to buy for this purpose. If the box has length, breadth, and height 80 centimeter, 40 centimeter, and 20 centimeter respectively, how many square sheets of paper of side 40 centimeter would she require? Okay, here we are going with total surface area, guys. Fine. Since Mary wants to place a paper on the outer surface of the box, the quantity of box required would be equal to the surface area of box of the shape of the cuboid. The dimensions of the boxes are: length is how much? Example 1. Length is 80 centimeter, breadth is 40 centimeter, height is 20 centimeter. So total surface area of a cuboid is 2 into LB plus BH plus HL. So when we substitute the values, that is 2 into 80 into 40 plus 40 into 20 plus 20 into 80. Then you get the answer as 1 11,200 centimeter square. Here they have given in centimeter, so you'll get centimeter square. Okay, clear? Then um when you have found the total surface area, but now what you have to find, they're asking the area. Okay, they're asking us the area of this. They're asking square sheets. How many square sheets should we require? So the area of a square sheet. But they're saying about the area. So how many square sheets of paper would she require if the side is 40 centimeter? Talking about area. So area of a square is a square, right? Side into side. Then that will be 40 into 40. It is 1600 centimeters square. Fine. Therefore, the number of sheets required equals to surface area of box by the area of one sheet of paper. Then we should divide 11,200 by 1600. Then 0 0 cancel. We get 7 as our answer. So totally we require 7 sheets. Okay, clear? We require seven sheets. Sorry. Going with our example 2, what does our example 2 say? Hamid has built a cuboidal water tank with lid for his house. With each outer edge 1.5-meter long. He gets an outer surface of the tank, excluding the base, covered with the square tiles of side 25 centimeters. Find how much he would spend for the tiles. If cost of the tiles is res 360 per dozen. Okay? Since Hamid is getting the 5 outer faces of the tank with the tiles, he would need to know the surface area of the tank to decide the number of tiles he required. So edge of a cuboidal tank is 1.5 meter. Actually, they have given everything in a centimeter and except the outer edge. So the outer edge will be is 1.5 meter. But when do we convert it into centimeter? We get 150 centimeter. It is equals to A. Okay. The surface area of tank, they have multiplied 5 into 150 into 150. Okay. So here you can see the area of a square is again there 25. So area equals 25 into 25 is the surface area of tank, cuboidal water tank with lid for his house. Just a second. Okay. So guys, just get it. Get the question. Then you will understand what are they saying in the question. What are they saying over here? Only the outer surface base is excluded. So the top is there. The top is there. So what can we do? 5a square is a formula for this. So 5 into a is 150 into 150. They have not yet multiplied it, guys. So the area will be, this is the total surface area, TSA. That means this is a new formula, okay? Not TSA, but this is a new formula because our TSA will be 6a square, right? So area will be 25 into 25. They did not multiply it. Okay, work smart. Okay, same like before question, guys. Then 5 into 150 into 150 by 25 into 25, which will be equals to 180. Clear? Now till here it is clear, right? Here we have found the number of tiles we require, like the before question. Before we said about the number of sheets we require. Now the number of tiles we require. Okay, so Abhi, what are we saying? If the cost of 12 tiles, that is a dozen, cost of 12 tiles equals to 360 per dozen. Now, if cost of 180 tiles equals to how much? This is a question. Okay, so 360. Um, just a second. Here, what we're talking about money, guys? No, right? How many tiles do we require? Is 180. So we have to, cost of 12 tiles is 360. So yeah, okay, I got it. So 180 into 360 by 12. Then the answer would be definitely risk 5400. So hope you're getting. Okay, in all the questions they won't give that the lateral surface area is there, or we have anything like total surface area, but they give some questions such way. So you have to understand the derivations. They might give you in the exam or they might not. But derivations are important. Okay, the same type things, the 5a square one, the same way you'll get many questions in the 13.1. So let's try to solve every question and understand. Going with 13.1, first one. A plastic box is 1.5 meter long. Here the length is 1.5 meter long. Okay, and its breadth is 1.25 meter, and its height is 65 centimeter deep. It seems everything they have given in meter except this. We have to convert it into meter. Okay, so totally we have 8 questions. We'll do it. 65 centimeters, when we convert it into meters, 1 meter equals to 100 centimeter. 65 centimeter equals to how many meters? 65 divided by 100. So 0.65. 1, 2, 1, 2. Okay. 0.65 meter. Now, what are they saying? It is opened at the top. Ignoring the thickness of the plastic sheet, determine the area of sheet required to make the box. Here, are we talking about anything called the top, or are we talking about the total surface area? No, the lateral surface area. We are saying it has opened at the top, so we are excluding the top, right? So that will be um, total surface area of a cuboid 2 into LB plus BH plus HL, right? This means 2 into LB plus 2 into BH plus 2 into HL. Now, one of the side, the top is having rectangle. So rectangle means L into B. So L into B means first one. So LB plus 2BH plus HL, 2HL is a formula. Okay? Clear? Now let's go on. Now let's substitute this one. Okay, the first question, the area of the sheet required for making the box. So L here is 1.5 into 1.5 into 1.25 plus 2 into what is breadth, 1.25 into 65, sorry, 0.65 meter, plus 2 into 0.65 into 1.5. Substitute. Okay, then you will get 13.1 answer as, just a second, 5.45 meter square. When you substitute all of this, you get 5.545 meter square. Here, why are we taking meter square? Because they have given us already about the meter square. Second one is dead easy, guys. You can think the total surface area is hard, but second questions are dead easy. 1 meter square is how much? 20 rupees. If what will be the 5.45 meter square? That is 5.45 into 20. Okay, 5.45 into 20 will be equals to the cost of 5.55 meter squares cost. Okay, so the answer will be 109 rupees. Okay, the answer is dress 109. Clear, guys? Going with our second question. What is the second question? The length, breadth, height of a room is 5 meter, 4 meter, 3 meter respectively. The length is 5 meter, breadth is 4 meter, and height is 3 meter. Find the cost of whitewashing the walls of a room and the ceiling at the rate of res 7.50 meter per second. Meter square. I'm sorry. I'm actually sorry. Fine. So gravitation, motion, ये सभी है ना, इसलिए I'm getting that one. Fine. Guys, here are we talking about the base? Okay, I mean here we are talking about the walls. Okay, four sides. That is the lateral surface here. Ceiling कहाँ पर रहती है? Walls पे रहती है. या bottom, like I mean, it will be on the floor. No, it will be on the top of the fan. Right? So we are including the top, including the four sides. So we are not including the base. So the same way of the second question. That means 2LB plus BH plus HL is a formula. Okay, and they're asking us the money. Okay, that will be easy. Just note it down, this questions. This easy. Okay, B is 4 into 3 plus H here is 3 into 5. Let's do it. 20 plus 12 plus 15, 16, 7, 27 plus 40, 7, 67. So 67 meters square, I think so. Let me check it. So yeah, here they have given mm, 1 meter square is how much they have given 7.50. Then 67 meter square will be 67 into 7.50. I have a doubt yet. Let me check it. Okay, so that will be answer as, that means 67 into 7.50. The answer is 500 and rest 555 is our answer. Clear? Going with our third question. The floor of a rectangular hall has a perimeter of 250 meters. The floor is 250. If the cost of painting of the four walls at the rate of rest, here they're asking about height. Okay, area of four walls equals to lateral surface area. The floor of a rectangular hall. The floor of a rectangular hall has a perimeter of 250 meters. If the cost painting, okay, so what do we have to do over here, guys? What we have to do? Here they have given the perimeter as 250 meters and 2 into L plus P, that is 250. Okay, I got it. So here the height is how much? Perimeter is given as 2 into perimeter formula, 2 into L plus P equals to how much? 250 meters. This you can see it in the formula, curved surface, lateral surface area of a cuboid. That is 2 into H into L plus P. Except H, you are finding everything. So 2 into H here, we don't know, we'll keep it the same. 2L plus P is 250 into H. This is what you get as lateral surface area. We did not know what is H yet. Okay, so as we know, here they have given 1 meter square equals to 1500. Then 250 into H equals to how much? 250 into 1500 into, okay, fine, I got it. I'm sorry, 1 meter per 1 meter square equals to here 10, right? So if it is 1500 for 250H, 250 into 10 by 1500, 250 into 10 by, then we'll get 22,500 by 15H. So then when we cancel, H will be equals to 6 meter. Clear? Going with our fourth question. What does the fourth question say? The paint in certain container is sufficient to paint an area. The paint in certain container is sufficient to paint an area equal to 9.375 meter square. How many bricks of dimensions 22.5 centimeter into 10 centimeter into 7.5 centimeter can be painted out of this container? Here dimensions: length to 22.5 centimeter, breadth 10 centimeter, height 7.5 centimeter. This is of brick. Clear? And the total area: 9.375 meter square. So here we are talking. First, let's find the area, total surface area. 2 into LB plus BH plus HL. L 22.5 into 10 plus 10 into 7.5 plus 7.5 into 22.5. Then we'll get some particular answer. Just a second. The answer we get will be 937.5 centimeter square. When we convert it into meter square, then it will be 0.09375 meter square. Clear? So as you can see, the number of bricks here we have that many will be equals to the area. Here the area is 9.375. Okay, so 0.09375 by 937.5 into 1 2 3, to remove the decimal points, 4 5 by 1 2 3 1 2 3 1 2 3 um 93750 93750 by 9375, we get this as 100. So 100. Guys, understand this question. First we should find the total surface area of the brick. Okay, that is dimensions are given. So total surface area, we'll get it as 9 937 937.5 centimeter square. So we'll convert into meter square. Why? Because the painted area is in meter square. 9.375 is in meter square. Now the here what are they saying? The paint in a certain container or to paint area is equal to 9.375, right? So here what number of bricks? The paint in certain container is sufficient to paint area equal to 9.375 meter square. This sentence is very important. Here what are they saying? They're saying that the number of bricks is equal to the particular one. So we have to divide 0.09375 by 937.5. 0.01, it is converted centimeter square to meter square. So to remove the decimal points, we multiply it by ones, tens, hundreds, thousand, ten thousands, 1 lakh by 1000, and everything will be cancelled. Then the answer will be 100. Clear? Going with our fifth question. Fifth is very easy. A cuboidal box has an edge of 10 centimeters. A cuboidal box has an edge of 10 centimeters. And other cubical. Cubical is 10 centimeters. Cuboidal is 12.5 long, 10 centimeter wide, 8 centimeter high. Okay, this is cuboidal and that is cubical. So first one, which box has a greater lateral surface area? Lateral surface area of cube is 4a square, 410 square. 400 is our answer. 400 centimeter square is a cube one. Cuboid 2HL plus B. 2H is 8, L is 12.5 plus 10. Then You get 360 centimeter square. Clear? Then here what you can see, cube have more lateral surface area compared to cuboid by 40. Okay, going with the second one. That what is second one saying, which box has a smaller total surface area? So total surface area of cube is 6a square. 6 into 10 square, 600. Total surface area of cuboid, 2 into lb plus bh plus hl. You get it answer as 2 into l here is 12.5 into 10 plus 10 into 8 plus 8 into 12.5. Then the answer will be 610. Okay, 610 centimeter square, centimeter square. Here cuboid is more by 10. Clear? Fifth question is done. Going with our sixth question. After eighth question, we'll take a 5 minutes break. Okay, because we have studied for a long time. From 41 minutes, we are studying. Sixth question we'll go through. A small indoor greenhouse, herbarium, is made entirely of glass pans, including base. Held together with tape, it is 30 centimeter long, 25 centimeter wide, and 25 centimeter high. What is the area of glass? Here we are asking about the area of the glass. As we know the total surface area, we have to find that one. So total surface area of a rectangle is, I mean a cuboid is 2 into lb plus bh plus hl is a total surface area, right? So 2 into l here is 30 into 25 plus 25 into 25 plus 25 into 30. Clear? So then the answer will be 4250 meters square. Clear? This is the first question. What is the second question? How much tape is needed for all the 12 edges? Okay, here asking about all the 12 edges. As we know, it is held with the tape. So we will divide it into halves. That means 4L, 4H, 4B, 4B and 4H. So 4L plus 4B plus 4H. Clear? You will do it like this. L here is 30 plus 4 into 25 into plus 4 into 25. Then the answer will be 320 meter as your answer. Clear? This is your answer for sixth question. Clear? Going with the seventh question. Very long question, but it is very easy. Two things you have to take in a view. Okay, small box, big box. Adding, subtracting, adding. I mean, subtracting is not that adding, doing the total surface area again, doing it with 5%. All such things are there in this. Let's start doing it. Okay. So, Shanti Sweet Stall was placing an order for making cardboard boxes for packing their sweets. Two sizes of boxes were required. The big, write it one side, small, write it other corner. At other corner you write, okay? Because we will do in both the ways. So bigger is in the dimensions of 25 centimeters is length, 20 centimeter is breadth, and 5 centimeter is height. The smaller dimensions, 15 centimeter is length, 12 centimeter is breadth, and 5 centimeter is height. For this 5% we are adding extra 5%, 5% extra. Cost is given for the cardboard. How much cardboard we require for 250 boxes? Again, we have to do that one also. First, let's find the total surface area of the big box. TSA 2 into LB plus BH plus HL. So 2 into L here is 25 into 20 plus 20 into 50, 5, sorry, 5 plus 5 into 25. Then the answer you will get is 1450 meter square. Centimeters becomes centimeter square. Clear? So 5% extra should be added, right? So 5% extra, then you have to do 5 by 100 into 1450. Then you will get 145 into 5, then you will get 725 by 10, which is equals to 0.72.5. So now what you have to do, the total area is 1450 plus 725. Total area equals to 1450 plus 72.5. Then the answer will be 1522.5 meter square. Clear till here? Now what are they saying? Now let's calculate for the smaller box. What will be a smaller box? So the same, total surface area equals to 2 into LB plus BH plus HL. 2 into 15 into 12 plus 12 into 5 plus 5 into 15. Then the answer will be 630 meters square. Clear? So now 5% extra, so 5 by 100 into 630, 0 cancel, 5 into 63, you will get 31.5. 315 by 10, that is 31.5. Then you have to, the total area will be 31.5 plus 630. Then you will get the answer as 661.5. Okay, both the sides you have to add for 250. So for 250 boxes it will be 250 into 15, 250 into 1522.5. Then the answer will be for big box, ones, tens, hundreds, thousands, 10,000, 3,80,625. 1625 meter square. For the small box, it is 250 equals to 250 into 6661.5. So the answer you will get is ones, tens, hundreds, thousands, and thousands. 1,65,375. 65,375 meters square. Now you have to cardboard required. Till here it should be written in columns, but from here cardboard required equals to 3 lakhs 8,625 plus 16 lakhs 53,075. This you have to add cardboard required for the small box and the big box. You need card not only for small box or big box, you need for both of them, so you have to add for both of them. So you will get 546,000 meters square. Okay, now for coming to the cost, what are they saying? They are saying 4 rupees is for 1000 centimeter square. Now converting, shall we convert it? No, right? We have meter square. Sorry, this meter square only. 4. So it will be for 4 rupees is for 1000 centimeter square. We have 546,000. So we have to, what we should do? 5 into, sorry, 546,000 into 4 by 1000. 1 2 3 1 2 3 546 into 4, you will get 62184. So 62184 is the right answer. Seriously, this much big problem, first onwards I'll explain you, just get to it, understand. I won't even take long time. Understand, 1 hour I think for exercise 1 only it took. Fine. So what are they saying? First, you have to calculate the total surface area of big. First, I'll complete big, then I'll go to small, then I'll come to both of them. Okay. First, coming to big box. In the big sweet box, you have to calculate the total surface area. The answer will be 1450. Now they said 5% extra. So 5 by 100 into 1450. Then the answer will be 72.5. Now you have to add the both of them because they are adding something 5% extra. 1450 is a box area and 5% extra is 72.5. So total box areas will be 152.5 meters square. Right, till here clear, right? Now they are saying for 250 boxes. 250 boxes. So 250 into how much you have to multiply? The answer you get, the total area, 1522.5. Then the answer will be 3,80,625. Small box. The total same way. Okay. Total surface area of a small box is 630. Now 5% extra. 5 by 100 into 630, then you will get 31.5. Now add those both. You will get 661.5. Now multiply it with 250 boxes. That is 1,65,375. So think how much cardboard do we require for the both the boxes? You have to add the total one. That is 3,80,625 plus 1,65,375. Then the answer will be 5,46,000. Now you have to know how much cost is it. They said that it will take 4 rupees for 1000 centimeter square. Then how much will be for 5,46,000? You have to think. That is 5,46,000 into 4 by 1000. You'll get the answer as rest 6,262,184. Clear seventh question, guys? Going with our eighth question. What does our eighth question say? Let's check. Last question of our first exercise. Then we'll go with our second exercise. Taking a small break, a short break. It's also very easy, but it's also long. So yeah, we have to do our best. Fine. Yeah, let's go with our last question. Praveen wanted to make a temporary shelter for her car. Praveen, Harra. Seriously. Okay, fine. So by making a box-like structure with tropylene that covers all four sides of the top of the car. So you are talking about all the four sides here. And what are they saying? Um, and the top of the car. Assuming that the stitching margins are very small and therefore negligible, would be required shelter height. Okay, clear. So what are they talking, guys? Are you understanding? They said, see, this is a main thing. Four sides in the top. They're not saying bottom. Then we'll get the first formula we have seen. 2LB plus BH plus HL is a formula. But here we are including, not including 2 for the first one. So LB plus 2BH plus 2HL is a formula for person. So L here is 4 and B is 3 plus 2, 3 into 2.5 meter into plus 2 into H is 2.5 into 4. So the answer will be 47 meters squared. This is our answer for eighth question. Clear, guys? So everything is done from our 8.1 till 8.1. Everything is clear, right? Am I right? Very good. So first problem is very easy. Very easy. Obviously, seventh problem you have to work hard. Then what else you have to work hard? You have to understand. That's it. Only seventh problem you have to understand. Next is the surface areas of right circular cylinder and the 11 problems. We will complete this today. Only this much we wish there. We should do all of these things for another 1 hour. So I say starting only be ready for 2 hours thing. Okay. Fine. Who is this? Huh? Fine. Okay, guys. So example 1, example 2, and example 4, 3, 4, 9 problems from our example third exercise 13.1. Try to read it. I'm not going to explain it in this class because it's only for 9th, but for the advanced knowledge I read it. Okay, understand? Clear? Okay, guys. So yeah, 2 minutes everyone, I mean till 1 hour, that means till 6 minutes, you all will be taking rest. Because overstudying is also not good. So we'll take rest for some time, drink water, have snacks for some time, watch TV, just be back in 6 minutes. I'll be also back in 6 minutes because even I didn't rest. After that, we'll again continue with our next exercise. Okay, guys, take rest. Okay. finally we have completed our 1 hour, and now we're gonna continue with again our subject revision. I'm literally feeling sleep. I made stop at middle also. Yeah, but even I'm even feeling hungry. I didn't even have anything. Fine. Hope you all have taken your break. Let's be back. Fine. Let's continue. Let's continue. What all we are reading now? Let us see. Okay. So we'll go with slowly, smoothly, and understand it. Okay. So if we take surface areas of a right circular cone, this one. If we take a number of circular sheets of paper and stack them up as we stacked as up rectangular sheets earlier, what would you get? Here, if we stack it vertically up, we get something called right circular cylinder. Since it has been kept at right angles to the base and the base is circular. Let us see what kind of circular is not a right circular cylinder. In figure 13.7a, you see, where did we go? Yeah, this is what we need. In figure 13.7a, you can see a cylinder, which is certainly circular, but it's not right angles to the base. So we cannot say this is a right circular cylinder. Of course, if we have a cylinder with a non-circular base, as you have seen B, then we cannot call it a right circular cylinder. Here we will find dealing with some right circular cylinders. So unless stated otherwise, the word cylinder would mean a right circular cylinder. Now, if a cylinder should be covered with the color paper, how will you do it with the minimum amount of paper? First, take a rectangular sheet whose length and breadth is just enough to go around cylinder to whose breadth is equal to the height of the cylinder as shown in 13.8. The area of a sheet gives a curved surface area of a cylinder. Note that the length of the sheet is equal to the circumference of circular base, which is 2 pi r. So, curved surface area of a cylinder equals to area of a rectangular sheet equals to length into breadth, perimeter of the base of the cylinder into height. 2 pi r h is a curved surface of the cylinder, where r is the radius of the base of the cylinder and h is the height of the cylinder. In the case of a cylinder, unless otherwise, the radius of a cylinder shall mean the base radius of the cylinder. If the if the top and the bottom of the cylinder are also to be covered, then we need two circles, in fact circular regions, to do that. Each of the radius r, thus having an area of pi r square, each giving us the total surface area 2 pi r h plus 2 pi r square, 2 pi r into r plus h. So the total surface area of a cylinder is 2 pi r into r plus h, where h is the height of the cylinder and r is its radius. You may recall from chapter 1 that pi is a irrational number. So the value of pi is non-terminating, non-repeating decimal. But when we use it, the value in our calculations, we usually its value as approximately to 22 by 7 or 3.14. Clear? So what all we have learned, curved surface of a cylinder is 2 pi r h, and right circular cylinder is different from the normal cylinders. Fine. And the total surface area of a cylinder is 2 pi r into r plus h. Let's go with our example 3. What does our example 3 say? Savitri had to make a model of a cylindrical kaleidoscope for her science project. She wanted to use chart paper to make the curved surface area of a kaleidoscope. What would be the chart paper required by her if she wanted to make the kaleidoscope? Length is 25 centimeter and radius is 3.5 centimeter. Here they actually given directly, it is a curved surface area. So CSA equals to 2 pi r h, right? So pi here is 22 by 7 into L is L here is h, length is h. Okay, height. Here length change into height. Radius is 3.5 into 25. The answer is 550 centimeters square because everything is given in centimeter. Clear? Going with our 13.2 exercise. What does our 13.2 say? First one, the curved surface area of a right circular cylinder of height is 14 centimeter. So that CSA is 88 centimeter square. Okay. So the diameter they are asking, that means radius into square. So we know the curved surface area is equals to 2 pi r h. 2 into 22 by 7 into r, here we don't know, into h is 14 equals to 88. So 7 into 2, 2 2s are 24, 44. So 88 into r equals to 88. That means radius here is 1 centimeter. So then the diameter will be 1 into radius, that is 1, sorry, radius into 2, that is 1. So diameter equals to 2 centimeter. Okay, this is the first question answer. Going with the second question answer. It is required to make a closed cylindrical tank of height 1 meter. Height is 1 meter. Diameter, base diameter is 140 centimeter. So radius equals to 70 centimeter. Then how many square meters of a sheet are required? So you can see here they are talking about height, base diameter. So what are we talking here about? We are talking about the total surface area because they did not mention anything. So you can see 70 centimeter is in centimeters, so 0.7 meter is a thing. So you have to do total surface area is equals to 2 pi r into r plus h. 2 into 22 by 7 into radius is 0.7 into 0.7 plus 1. Then the answer will be 7.48 meters square is the answer for the second question. Going with the third question. A metal pipe is 77 centimeter long. This is a very important question, guys, but it is a tricky question in the third one. Only total surface area, but first and second are easy. So metal, it is 77 centimeters long. It is 70 centimeters long. This is a height. Find the inner diameter is 4 centimeter. So the outer diameter, huh? The outer diameter, inner diameter is 4. Outer diameter is how much? Outer diameter is 4.4 centimeter. Fine. So now first one they are asking to find the inner curve surface area, that is 2 pi r h. So 2 into 22 by 7 into radius, here we have, okay, third one, right? So it is 0.02 because here first we have converted 4 into 2 centimeter because it's a radius. Then it is centimeter to meter. So it's 0.02 into 77. Then the answer will be 968 meters square. Going with the second question, the outer curve surface area, same, 2 pi r h. 2 into 22 by 7 into 0, what is the outer? 4.4, right? So you can take 2.2. Then after that we will do 77, that is 10464.8 meters square. Going with the third one, What is the third? Total surface area. Here total surface area is inner curve surface area plus outer curve surface area plus 2 pi 2 pi, that is r square minus r square. This is what is the third one. So we'll get the answer as 2038.08 meters square. So tomorrow video will have upon this third question of third one. We will third question totally we will do it tomorrow. So 4 5 from fourth question we will do it guys later. Now you have your break. Fine. We will do it later. Okay, guys. So please take care of yourself. We'll be meeting again after some time. Maybe at 9 o'clock or something. So 10 minutes, we have completed four problems. We'll meet you again back. Bye bye. Have a nice day. Take care of yourself.